Hello again, everybody. This is Mr. McLean with another math video called The Power of Exponents, Part 1, Exponent Basics. With me, as always, is my assistant, Absissa from Solution Squad.
Hello, everybody.
And before we start talking about the value and power of exponents, let's review real briefly the prime factorization process. And now, Absissa, give me a number that you would like to see the prime factorization for.
81.
All right, let's use 81. Here we go. So if we take 81 and we break it down into its prime factors, the first thing we're going to do is make it down into 9 times 9. That's the easiest way to do it. And then with 9, you can break that further down, because they're also composite numbers, into 3 times 3. Now, since both of those are prime, we're finished with them. And this one also breaks down into 3 times 3, and we're finished with them. So the whole point is here of writing down the prime factorization is writing all the factors, 3 times 3 times 3 times 3. That is not a very efficient way of writing 3 times 3 times 3 times 3. So because of that, we express them using an exponent. Whenever we have repeated factors like this, 3, 3, 3, and 3, we can use these tools to help us write it in a simpler form. We're going to write the 3 as a larger number called the base. The base is the factor that's multiplied over and over again. The exponent that we're going to use is 4. And that is telling us how many factors of the base that we have. So we have 4 factors of 3, the exponent and the base. And that is how you express a number in exponent form. Now, what if we're trying to move it back again? What if, for example, I have 6 to the 4th power? Absissa, how many factors of 6 would I write?
4.
That's right. So I would write 6 times 6 times 6 times 6. And that's what we call expanded form. Any questions so far?
No.
All right. We'll be right back. All right, and we're back. Part 2, traps and pitfalls. Now, the reasoning behind working on a video like this is that we want to prevent you from making common mistakes that happen all the time when we're talking about numbers in exponent form. One of the most common ones is that people will say 2 to the 3rd power makes 6 almost 80% of the time when they don't know any better. But let's talk about why 2 to the 3rd gets confused with 6. Primarily, it's because 2 to the 2nd power does make 4, so people naturally think that you multiply the base times the exponent. And that does work occasionally, but not very often. In fact, 2 to the 2nd does make 4, just as 2 to the 1st power does make 2. So people naturally assume that 2 to the 3rd power makes 6. And I'm sorry, but that's simply not true. You can also get confused because 1 to the 1st power makes 1, so there are a couple of them that work this way. But let's talk about what the powers mean first of all. 2 to the 2nd power is 4 because it's 2 factors of 2. So yes, that one does make 4. This one is 1 factor of 2, just as this one is 1 factor of 1. So those do work, but why doesn't this one work the same way? Because you have to remember, what does the exponent mean? The exponent tells us the number of times that we multiply the base. So 2 to the 3rd power does not make 6. What do you think it makes? 2 times 2 times 2. What is that, Absissa?
8.
That's right. That makes 8, not 6. And the thing is, the higher the exponent gets and the higher the base gets, the bigger the mistake gets. I'll give you another example. We were just working with 3 to the 4th power a minute ago. Watch what happens when we work 3 to the 5th power. Now, if someone thinks that's 15, that would be a very interesting guess. But watch how wrong they would be. 3 to the 5th power is 3 times 3 times 3 times 3. Now we know that's 81, but we still need one more factor of 3. And 81 times 3 is 243. So if someone guessed 15 for 3 to the 5th power, how wrong would they be? They'd be extremely wrong. So you have to be very careful about when you're looking at exponents to not simply multiply the base times the exponent. It doesn't work that way very often. So be careful of these traps and pitfalls. And we're back with the power of exponents, part 3, multiplying exponents with like bases.
Oh, I Brother Ordinate.
Hello, sister. Look out the door. It says we have a mission. We must go quickly. Well, I'm sorry to see Abscissa had to run off, but that's not going to stop us from learning. For multiplying exponents with like bases, we're going to switch it up a little bit. We're going to use variables to represent the base instead of regular numbers, because we don't want to get bogged down worrying what 5 to the third power actually makes. So for our purposes here, right now, we're going to use, a for a variable. Now remember that a variable is simply a letter or symbol that takes the place of a number or a set of numbers. So if I say a to the third power, try and remember that that means 3 factors of a, whatever that number happens to be. Now, if I multiply that by another one that has the same base, and we call it a to the fourth power, how are we going to do that? Well, basically we have to break it down and remember what they mean. A to the third power means a times a times a. In other words, 3 factors of a. And a to the fourth power means a times a times a times a. 4 factors of a. Now when you multiply them all together, you have 1, 2, 3, 4, 5, 6, 7 factors of a. So this makes a to the 7th. Now a lot of people like to use rules and shortcuts to try to remember how to do that. And that's fine. You can do that so long as you don't forget the rule or the shortcut. If you break it down into what it means really quickly, if you're working on a test or working on a paper and you're under a time constraint, then just break it down real quick and make sure that you remember the rule correctly. So yes, when you take like bases and multiply them, the trick is to add the exponents. The reason why is because you have 3 factors times 4 factors, which makes 7 factors. Now to prove this to skeptics who don't believe in using variables, let's do it the same way again, but this time let's use a number as a base. Let's use, for example, 2. Let's say 2 to the third power times 2 to the fourth power. Now, really quickly, let's break that down and remember that 2 to the third power, not 6, remember, 2 times 2 times 2, and what does that make? 2 times 2 is 4, times 2 is 8. So keep that in mind, that makes 8. Now, 2 to the fourth power is simply one more factor of 2 piled on top of that, and since that was 8 right there, 8 times 2 is 16. So 8 times 16, let's see, 8 times 10 is 80, 8 times 6 is 48, so 80 and 48 makes 128. Now, if that's the case, then 2 to the third power times 2 to the fourth should make 3 factors, 4 factors, 2 to the 7th power. Check that with your calculator. 2 to the 7th power is 2 times 2 times 2 times 2 times 2 times 2. It's not like a broken record if anybody remembers what that is. Times 2. 2 times 2 is 4, 8, 16, 32, 64, 128. Sure enough, 2 to the 7th power, 128. Now we're really going to mess things up by using variables for both the base and the exponent by writing something that we can use for the general rule. And that is to say that a to the m power times a to the n power. What was that trick again? We took the same base, we kept the same base, and then what did we do with the exponents? It was 3 and then 4, so we had 3 of them and then 4 of them. We added them together. So we add together the exponents here, a to the m plus n. Now, the thing we're going to do next is going to get confusing with that because a lot of people get confused with this rule, a to the m raised to the n. And that is something different entirely. And that's what you'll see next.